research I'm involved in is related to traffic signals. And so we've been working for the past 20 years to try to make traffic lights a little more effective. Everybody knows that sitting at a red light when there's nobody in the other direction is a very frustrating behavior. And so we try to change the lights so they're a little more adaptive to traffic flow. We built a system, we tested it out on Speedway, and it's being used in a few places around the country. And then we began to look at special kinds of control, like the work I'm doing right now is related to priority for emergency vehicles in transit. And so the way it works today, and everybody's used to this, you see a fire truck barreling down the street with a light blinking on it, and there's a little infrared beacon that sends a message to the signal that says, I'm a fire truck or an ambulance and I'm coming your direction. And the traffic signal does some logic to try to let the vehicle through the intersection a little more efficiently. But the problem with the existing logic is it only works for one vehicle at a time. And many times there's more than one vehicle that approach a traffic signal. So here's an example, March 30th, 2009, Houston, Texas, two fire trucks collided at an intersection. The drivers of the vehicles both said, we expected to have a green light because we knew the intersection was equipped with a new preemption system. And this is the downfall of the preemption system. It's one vehicle at a time before they serve any other vehicles. So this occurred here. A 29-year-old woman was on a bicycle and she's underneath the fire truck and she didn't make it. So there's multiple. Here's St. Louis, October 10. Here's Brooklyn, October 23rd. And the stories go on and on. So what we're trying to do is have the logic be able to accommodate multiple vehicles as they approach the signal in a very safe and efficient way. This is a microscopic traffic simulation model of Speedway. So this is the intersection of Speedway and Campbell. We do a lot of research here in the lab studying the behavior of traffic signals and drivers at this intersection. The little blue boxes are the detectors that are very much like what we have out in the street that call the traffic signals and make them cycle through. This is called a software in the loop, a SIL. This is the actual control software that's used out in the street. This is a connection to the City of Tucson's video detector network, so we can connect and look at an intersection. This is the intersection of Campbell and 6th. This is an ASC3, an Econolite traffic signal controller that's hooked up to a device that lets us connect it to our simulation model so that instead of using software, we can actually use the hardware. So at each stage of our development and testing, we get closer and closer and closer to what will actually be out in the street, and then eventually we can go to the street and do our testing. So this traffic signal cabinet the city put in for us right here allows us to locate some of our equipment that we're using for testing. So there's a communication network of fiber to every intersection here along Speedway from Euclid to Alvernon that connects to the city network through UITS. This is just an empty cabinet. It's not an active traffic signal cabinet, but we can put controllers and devices in here and do our testing out here in the field environment. This is a piece of equipment beyond a vehicle, like a bus. If we wanted to give transit priority to the buses, we locate this, and it has a GPS receiver, a DSRC radio, a Wi-Fi radio, and a Bluetooth radio. And this communicates the position of the vehicle, like the bus, to the intersection so we can do our signal timing strategies. The wireless communication between these devices and then the network in the cabinet is wired with fiber optic back to the lab. So the U.S. Department of Transportation, in cooperation with the auto manufacturers, is looking at having this a required piece of equipment in every vehicle. The analogy is seatbelts. Back in the 60s were required to be in all new vehicles, and it took 20 years before everybody had seatbelts, but pretty soon everybody will have an onboard equipment, and this will make it a safer and more efficient roadway. And that's what we're working on, is the algorithms for signal control. I really believe that in about 5 years you'll begin seeing this new technology in vehicles. It will be safer to drive, it'll be safer for pedestrians and bicycles, it'll be more efficient the way we time the traffic signals. 20 years from now, I would expect, much like when seatbelts first came around, every car will be equipped with technology, and then we can really make a difference in how traffic signals operate. Maybe we'll let you go through a red light if there's nobody approaching in the other direction, rather than waiting for the light to change and then change back. In the future, we add maps and all kinds of new technology that's out there. We have vehicles that are equipped. We have handheld devices and pedestrians that are out there. We have transit vehicles that may be equipped so they can get through the intersections more efficiently. We have fire trucks. There may be multiples of those. And so all of a sudden we have this whole picture of an equipped intersection where we can make intelligent decisions. It's fun to be on an airplane and look out the window and look down at a city and see the traffic lights, you know then how many traffic lights are out there and how much impact you can have. There's 375,000 traffic lights in the United States right now. And so that's a huge impact on people's lives.